Massive models have been getting a lot of attention lately, but you've probably never seen a model with 1 trillion parameters. So this is pretty interesting. This is sort of a joke, but actually this has been created successfully. And there are a few different versions, so if you can't manage to fit 1 trillion parameters into your personal GPU, there are a few other options that might fit if you multiply your current GPU count by maybe 10. So this is a project from Maxime Leban, and I think it's pretty cool. And it builds on some earlier projects he's done with Llama 3.1 and making them ridiculously large and still seeing some really quirky performance improvements. There are also some really interesting releases that came this morning from Meta with basically a re-release that is a slightly smaller and much more efficient version of their largest flagship model, Llama 3.1-1T-Instruct. So I'm excited to talk about both of these models. Welcome to AI Flux, let's get into it. So what's wild is this model hasn't been trained on 1 trillion tokens, it's actually represented by 1 trillion parameters. And it's basically just a merge of a few different versions of Llama 3.1-1T-Instruct. But what do we actually get from this, and why did Maxime actually do this? So this is actually the direct successor of Llama-3.1-1T-Instruct, which again was a self-merge of Llama 370B that produced really great results in things like creative writing, and however, definitely fell short in areas like programming and things that required a little bit more accuracy. What's interesting is really big models that come from merges in the past were kind of useless, and what's interesting with Llama 3.1 is they actually seem to have some really interesting applications that make sense, and creative writing is one of these. What's interesting is when you really start to see what the long context window starts to do at these massive parameter counts, and I can't actually run this right now. I'm working on that probably for early next week, but it's really cool to see what Maxime has reported here. And hopefully Cognitive Computations with their GPU sponsor will be able to give us some insight as to how this model actually performs. So for the 1 trillion parameter model, it's basically just an experimental self-merge using MergeKit with MetaLlama, Llama 3.1-1T-Instruct, and the stock Llama 3.1-1T-B model. There are a number of duplicated layers, so this model is pretty unruly if you manage to run it, but it's cool that it actually works. And what's funny is Maxime actually made a much smaller version of BigLlama-3.1 that actually only has 681 billion parameters. So it's not quite a one-to-one merge or like an addition merge of Llama 3.1-1T-B, but it still does some interesting things. And what's crazy about this model as opposed to the previous Llama 3.120B or previous BigLlama is that it's actually really good at coding, which makes no sense because the last version of this was actually pretty bad at coding. It was hard to keep it focused. And one thing that's interesting is in certain cases, when I was messing around with merging would actually make models harder to keep on point and harder to focus. And the structure and or just the data that was used to create Llama 3.1-1T-B is such that it has completely inverted this behavior, and massive models like this are actually much easier to keep on track or on task in certain cases. So again, there's also this 681 billion parameter model available. This is likely what I'm going to run once I get up and running with my new GPU sponsor, which I'm really excited to announce early next week. I'm still waiting for their embargo to drop. And so basically what we have to wait on here is for the quants to come and or for me to get more GPUs. What's cool is we're going to see more things this model is good at that previously massive models were just really bad at, and benchmarks will also be soon to come. It's kind of interesting because a lot of people thought that since huge models exist now that Franken merges would be a thing of the past and that merging would kind of stop giving us more performance improvements. But what's cool is Llama 3.1-1T-B came along at a time when we actually finally had figured out kind of actually how to quantize it and also realized how to merge it effectively. For the first few months that Llama 3 was out, no one really actually knew how to do that. And hopefully this means we get even more powerful quants, specifically instruct quants, which is another really important aspect of this model. And I'll link the Hugging Face below, which gives a bit more information. And in theory, yeah, this is where you'd get it if you'd want to quantize as well. And the next thing that was pretty cool that happened this weekend, actually this morning, is Meta actually pushed an update, actually improving a number of attributes of Llama 3.1-1T-B. So the initial release was really powerful, but it wasn't necessarily the most efficient version or efficient way to run this model. And I'm not going to get too into the weeds, but there are a number of attributes with models this large that either make them a little bit easier to run or a little bit more efficient with how they actually utilize all the layers in play when you're running inference. And when you're a bit more clever with how you're addressing these layers and how you're actually using VRAM, you can start to shave pretty significant portions off. And although they don't really highlight this in the model description, you have to dig through the initial paper and some of their Git comments in their release. But this model is actually about 20% more efficient in terms of VRAM and physically quite a bit smaller than the original Meta Llama 3.1-1T-Instruct. What's also funny is the model size in Hugging Face comes up as 406 billion parameters, which is kind of interesting. And there's actually a fantastic thread on Local Llama that breaks down some of the other sort of less foreseen or harder to find advantages of this model. So I'll link to this below, but basically the big change here is that Meta changed the number of KV heads from 16 to 8, which you'd think, well, if you're going from 16 to 8, this would make it a bit less performant or slower to actually get through inference. But what's cool is if you diff the white paper, you can find that it's not just a configuration change, but the entire model structure and architecture has actually been updated to work with this. And what's really interesting is the Hugging Face staff actually shows up in the Local Llama subreddit quite a bit, and they've given us some really great insights here. So basically, it's the same model using, again, 8 KV heads rather than 16. In previous conversions, there were 16, but half were duplicated. So generally speaking, this is a pretty big win, and we're not really losing much from this. It's enabling much more efficiency and making sure that you're using VRAM for things that actually matter and not just storing duplicate weights to infer on. It's actually something that Hugging Face has worked with Meta and the BigLlama team to work on in the past, and it should bring some nice speed improvements along with upcoming versions in the future. And roughly, this equates to, again, a 20% reduction in VRAM that you need to run the largest version of Meta's Llama 3 model at full precision, which is really, really cool. So hopefully this means we get better quants faster. It means that in the future, merges will come out faster. And also it means that, obviously you still have to be pretty GPU rich to actually run this in its raw form, but less VRAM to run bigger models at greater precision is basically always a good thing. And Llama clearly sees this as a direction they want to take going forward. And, this is curiously something that took a while to come around to full-fledged text-only or text-to-text large language models. It's been a really common thing in generative AI since lots of people initially were more interested in making images with their GPUs instead of just text. But hopefully this continues and we start to see really awesome performance gains with relatively simple architectural fixes that still basically have to come from the producers of the base model themselves. So I'm curious if any of you are actually even able to run this 1 trillion parameter merge of Llama 3.1. I'm curious if any of you are going to hop on this brand new model from Meta and start quantizing it to see if that 20% reduction in VRAM actually makes things faster or much more just pleasant to work with. Let me know in the comments below. I'm really excited that based on our last video, I'm going to actually be doing an interview with the founders of BRX. So it's not scheduled yet, but that is now in the books, so stay tuned for that. And as always, I hope you learned something from this video. If you like our content, please like, subscribe, and share, and we'll see you in the next one.